Why, hello there. My name is Daniel Haskell, and this is Lambda Calculus as explained to a Rubberduck. This is a programming language I'm learning on my own time, and also this video is my submission for the Stembassador program. For some basics, Lambda Calc is unrelated to the similarly named mathematical field of calculus. Lambda Calc is used as a notation to represent computer functions, which are code intended to be reused. It does this by abstracting them and applying said function to an argument, which is an expression input into a function. This sounds complicated, but is actually quite simple, as we'll go over later. Lambda Calc can be used to simulate a Turing machine due to some computing stuff, though I don't have the time to review that in this presentation. So this is what a function looks like. This is the head of a function. The lambda simply means that the function y begins in the parentheses. This tells us what to replace when resolving. This is the body of the function, also known as an expression. This is the information a computer will end up executing. Variables can be freely replaced when resolving this function. What all that stuff means. Letters are variables that represent similar things. Their name is interchangeable without changing the rest of the code in the expression. However, when two expressions are given the same name, they must perform the same action. Expressions can consist of as little as one letter, typically in groups of two or more. Parentheses in this instance act sort of like the order of operations, used to show a snippet of code occurs separately from the rest of an expression. Functions perform nothing on their own and need to be followed by or resolved by another expression. There's more on that later. Now for the fun stuff. So resolving a function. This is our function here, and this is a separate function called hi. Before resolving, it looks like this, but after resolving, it looks like this. Here's why. So you resolve function y by replacing all occurrences of the variable in the body of the expression, which is this, with the other expression, in this case, hi. The head of the function, which was aforementioned, that's this thing here, simply tells us what to get rid of in the body. Now that the expressions have been abstracted, we can say goodbye to the head, which bye-bye. Some other clarification, keeping this as short as possible. Functions are like Russian nesting dolls. Functions can contain other functions, so functions can be in the bodies of other functions. Your objective when abstracting a function is getting rid of all the pesky lambdas in the heads of the expressions you are abstracting. Resolving a function is like creating an acronym. We all know DHS stands for Delaware in high school, but so here's a quick explanation of that principle. This is, of course, not following syntax. Here's a demo here. This is what you already know, but want to remove from the expression for brevity. This is another variable we want to apply to the resulting expression. This is the repeated expression, the thing people say, that you would like to abstract. And this is another expression you would like to resolve alongside one specified after the lambda. And of course, this would result in the results of go to DHS. I don't have time to go in that much depth. Wrapping up, for the sake of time, and because I know you're probably tired of my voice, this is the end of my presentation. If you'd like to look further into this programming language, please look at the sources below, some of which I used to brush up for this video. My explanations are my own. If you spot any inaccuracies, please feel free to contact me and help clear them up. I hope that fits within the time frame. Thanks for watching.